Okay, for this next one we need the manual, so that's on the other side of the screen there. So for part A, this we're asked, other than the program-specific logic, what should happen in an interrupt handler and why should it happen there? So we've talked about this a few times, but the main thing that has to happen is that we have to unset the interrupt flag. So that may vary from interrupt to interrupt how we do that, but we always have to unset that flag somehow. So that's the thing in the hardware that indicates that we should call the interrupt handler. If we don't unset that flag within the interrupt handler, the hardware might assume that we still have a problem. So this happens for interrupts like hard fault in particular. Whenever we have a memory error, it is potentially possible to handle that memory error and fix it. But if it hasn't been fixed, then we shouldn't unset the flag. We should just try again maybe and leave that flag set. And so it's best to sort of leave the flag set if it might need to be handled a second time. And so the hardware will not do this by default, but it is usually the case that we want to unset the interrupt flag in most normal code. So we have to do that, and we have to do that as part of the interrupt handler is to unset the flag. Why it has to happen there is so no duplicate interrupts. So that's it for that question. It's really just looking for those two things, making sure you understand that you have to unset that interrupt flag somehow, and that the purpose of that is to prevent duplicates. So moving on to the next question, assume that an Ethernet message starts when the line changes from 0 to high, 0 to low to 1 high. You can read the received bits directly from ENET RxD0, show any bits that should be set in X mode, X polar, and pin cell 4 to trigger an interrupt on EINT1 when a message starts. Leave any unchanged bits blank. So the sort of key things here are we're changing these three memory locations, so we'll need to know what those look like. And we want to do this for EINT1. So let's go ahead and we're going to find X mode in our document here. And let's go ahead and search for that. Find the correct table, and we can sort of jump ahead to this. So X mode is level sensitivity or edge sensitivity for the device. We want to know when it changes, so we want to use edge sensitive. We want to do that for EINT1, and so that means we're going to be setting bit 1 of X mode to 1. So that's the only thing you need to change here for this problem. Then we can scroll down to X polar because it's right there. That we could search for that as well. And we need to read that in this case we're again doing int1, so it's going to be bit 1. And we want to know whether it's going to be low active, falling edge sensitive, or high active, rising edge sensitive. From the problem, we're detecting changes from 0 to 1, so that would be rising edge. And so again, we're going to set X polar to 1. Okay, and then the last thing that we have to look for here is to find our pin cell 4, and that is the pin connect block. We can find that either in the menu or by doing a search for it again, and we'll need to see that EINT1, to use that, we have to set bits 22 and 23 to function when 0, 1, and that sets up EINT1. So 22 and 23 need to be 1 and then a 0 there. And that's all that had to be set here. For the last question, what pins on the board need to be connected by wire to allow the external interrupt EINT1 to trigger when ENET RxD0 changes from low to high? So for this one, best to look up ENET RxD0 and find that in the manual. And you should eventually find where that is in the pin select values. So we know that now that is coming out of pin 1.9. That pin we would do pin cell just the same way that we did for GPI, or for the other pin that we looked at previously. But we know that we have to connect 1.9 to pin the one that we looked at before, which is the EINT1 pin, which is 2.11. And so we're gonna jump those two pins, and that's going to allow us to read the value on EINT1 that is being sent in via ENET RxD0. And that's it for this problem.